start. Thank you for joining us today. And what we will be talking about. Imagine when you start a project, do you have only one way to structure this project? Or do we structure it in different ways? Or maybe, do you ensure that the project that you are working on is working only on your computer right now or will be working for any other person? So do you care about reproducibility? Do you have one way to make the project reproducible? Just chew on it for a moment. According to the Zen of Python, that we probably all know, there should be one and preferably only one obvious way to do it. But unfortunately, from our experience, there isn't, especially when the problem is complex. So in reality, there is no one way to do things right. So if you wonder how Python projects are structured usually, and what is the most common pattern that the projects are using, this talk is for you. If you wonder also how reproducible are Python's projects in the wild, and then this talk is also for you. And if you like to confront your intuition with data, this is definitely for you. So who are we? Zhang and I are working in Modus Create, which is a consulting company that supports clients in digital transformation and also develops software application, including the Gen AI ones. What makes us unique from the consulting companies is Tweak, the OSPO of Modus Create, which is open source program office, where we maintain and contribute to open source project. With Johan, we make FawltyDeps team, and you might wonder what FawltyDeps is and how it's relevant to this talk. And FawltyDeps is the library that we are working on and is a dependency checker that finds undeclared and unused dependency in your Python project. So while FawltyDeps is good for this stuff, that got us thinking, because we had a great tool at our disposal, but could we use the expertise also that we built while building this tool to check how Python ecosystem works in general? So what are the trends and widely adopted practices? And for example, if the different communities in Python use Python differently, like scientists versus developers. So Zhang is data engineer and has a PhD in mathematics. I am also a data engineer and also have a PhD in mathematics, and you see where this is going. So we love data and we want to crunch this problem by analyzing that. So first, let's dive into structure. So you start a data science project. You have data. You are happy. You extract this data. You do some analysis. OK. Of course, you have utils, because everyone has utils. Then you end up with some more like general purpose Python files. And it goes on and on and on. And it starts getting a bit long. And then at this point, you forget about this project. And it just evolved into something very weird. And at that point, 3 months later, someone asks you, well, could you run this analysis? Or where could you change something in this analysis? And now you don't even know where to start, because you don't know where your things are. Just take a look. There is no documentation, README, or whatever. So wouldn't it be nicer if you have the structure to your project, like data in data folder, notebooks in notebooks, scripts and script, and so on? Yeah, probably would. Even better if you have PyProject Tom that governs your dependencies, and README that will keep the user understand, user being you, of course, in those 3 months, what was done in the project. So with the code structure, it's with like the tidy home. If you mix things that shouldn't be mixed, you can end up with an unpleasant failure. Like in this picture, you see the shaving cream and the toothpaste are very not nicely close to each other, and you see where this is going. So we identified following structures to be most common, and that will be the categories that we will be checking in our experiment. So first one is the structure that has the same name as the project. So project foo structure that has main code in foo directory. There are some projects that are using source main directory. There are some that do not use any main directory at all. And there are some that are using different name, including projects that are, for example, namespace packages. But we will not distinguish that separately. So this is all of the project structures that we will be researching. And our hypothesis was that given the Python projects are using cookie cutters, maybe a lot, maybe sometimes, so they initialize a project with a structure like, I don't know, DBX for Databricks or CrewAI for AI agents, we will most likely have a lot of projects with the same name, so the one foo. So let's see what we will find. And the second thing that we wanted to check in those projects is reproducibility. And for science, it's obvious that reproducibility must take place because you cannot convince other people that it works unless they cannot redo the experiment, and also for stability of programming performance. So following Anaconda blog post, there are several levels of reproducibility, and only a few of them will be right now of interest to us. First, it's not reproducible at all, because I don't know, maybe you put all your files in temporary directory and you don't have access to it anymore. Then, reproducible only by you and only today. Then reproducible by other with guidance, so if you put some how-to, they can do that. Reproducible, but only today with the internet access, so this can be projects that have, for example, dependencies declared, but really they are not locked. So you do not know the particular version of the dependency that you are using. But if you do know the version number, you can reproduce it anytime with the internet access. So that's the place we would like to be, and this is good enough. There are several other levels, but we'll not dive into that. So, are there any data scientists in the room? Data analysts? Okay, I see there's some of us, some of you. So you know this, you've been there, right? You are running in your beautiful notebook some code that will take a lot of time. And after a while, you discover that it failed. And it failed because you do not have this dependency, this pandas dependency in your environment. And it is super annoying when you are training neural network, for example. So the same thing may happen with your project, not only with your notebook, if you don't declare dependency and don't make your environment reproducible enough. So for this one, our hypothesis was that top PyPI projects, which were part of our experiment, have to be reproducible, because otherwise users would be super unhappy that the tool that they want to use is not doing the same thing every time it's run. But the scientific project might not be as reproducible due to different objective of its creators. So people might not put that much attention to declaring dependencies, for example. And as for the structure of the project, we also had some hypotheses for the start of our experiment on the dependency declaration. So we think that the most popular way of declaring dependencies is still a requirements.txt file, which you can just declare dependencies without any version number or version constraints, but you can add those version constraints. Another way of declaring dependency is setup.py, in which you can either import requirements.txt or just straight declare your dependency in install requirements field or extras required. I think there was one more, but it's not important right now. And there is the PyProject.tom, which is right now the suggested way of declaring your dependencies. And on top of that, it is also a configuration file where you can configure all your other tools, not only declare your dependencies. So for example, in that case, there is a configuration for black, so the formatter. So this is the the experiment setup that we started it, and the hypothesis. And now I give the floor to Jihan to present you the experiment and its results.
Yeah, thanks Maria for the introduction. So let me tell you more about the experiment and the results. So first, the experiment. So let's start with the data. So to find some interesting insights, we picked two categories that seem to be like really different. So one is this biomedical data, which is sourced from some scientific biomedical articles. And the other one is the PyPI data, which is a list of most downloaded PyPI packages. So if you are curious, I will just show you some like a snapshot of the data. So you can see that for biomedical data, they come from different subjects, like technical nodes, like software or research. And for PyPI data, it is sorted by the this annual downloads in 2023. So maybe you can find some like familiar packages here or not. Okay, so these are the data we will do the analysis on. And the next question is, what metrics did we collect it? So as Maria mentioned before, our objective was to explore how biomedical projects differ from top PyPI packages, especially in terms of code structure and reproducibility. So first, for the code structure, like where they put their code. So we reused some of the FawltyDeps directory traversal feature to count the number of Python codes in the top-level directories. And then we grouped them into these 4 categories, as mentioned before, like same name pattern, source pattern, root directory pattern, and different name pattern. So the second metric we will collect is this reproducibility. So how they declare dependencies. So there are like some may use requirement.txt, some may use poetry to generate some pyproject.toml, some may use setup.py, or mix of the above, or they don't declare any dependencies at all. So these are the 2 metrics we collected. And then how we collect them. So first, we have a list of like this project names and source code URLs. And then we downloaded them and uses FawltyDeps functionality to collect them and proceeded with cleaning the data and then do the analysis. So in the end, we have like 1,260 biomedical projects and 1,118 PyPI packages. So although the number, like the absolute numbers are not exactly the same, we just think they are comparable and we want to see if we can find something fun. And if you're wondering whether our experiment is reproducible, the answer is yes. So we've created like a separate branch of FawltyDeps for the experiment, and we also set up like a dedicated analysis repository called FawltyDeps Analysis. So here comes the results. First thing first is this structure code. So you can see from the bar chart that the blue ones are the biomedical projects, and the orange ones are the PyPI packages. So for the blue ones, they always, not always, like over half of them follow like this different name pattern. While for PyPI, there's like a third of them follow this different name pattern, and another third of them follow this same name pattern. And if you look at this root directory pattern, you may we were a bit surprised that for biomedical projects they are like 2 times larger. Like the number of them they store all the source code just in the root directory is like many. So, and when we looked at what they are like, we just found that a lot of biomedical projects, they might be a loose collection of notebooks or scripts. So that also makes sense that they don't need to add any like subdirectories at all. And then for reproducibility, the first question would be like, who declare dependencies? So for biomedical projects, there are like about 60% of them declare dependencies, while for PyPI, there are like 99.9% of them. So that's like another surprise to us. But we are still wondering, like, for PyPI, it is well done, but is it like too good to be true? So think about the example Maria mentioned before. If a project uses like setup tools to package the project, the dependencies can be found in like install requires or extra requires blocks. However, for some projects, they don't declare any dependencies in it. They use setup tools just to save their metadata and package their projects. So like this. And this is like obviously not in our scope, because what we care is the projects that declare they really declare dependencies instead of just have these files. So we can see this inner pie in this pie chart. Like for biomedical projects, there are like half of them have real dependencies declared, and for PyPI packages, there are like about 80% of them have dependency declared. So next question is how they declare dependencies. Do they have some preference, like a preferable way to declare their dependencies? So like we have these three groups, like requirements.txt, pyproject.toml, and setup files. These three groups are not exclusive, and we can see that like for biomedical projects, like using requirement.txt or setup files, they're like a majority, while for PyPI projects, there's like a higher occurrence in pyproject.toml. And then if we take a look at the Venn diagram, we can see like the overlaps between among these three groups for biomedical projects and PyPI packages. So we can see that like for PyPI packages, the green one, hopefully it looks green to you. So the green one is like larger, and it has like more overlaps with the other two groups. So why it behaves like this? I think each of us may have a different answer. So as data scientists, as data engineers, we have some like opinionated analysis. Like for biomedical projects, they are not necessarily importable, while for PyPI packages, they are written to be reproducible. So that may explain like why there are like so many PyPI packages declare dependencies. And for the preference of the methods, of the dependency declaration method, for biomedical projects, they tend to follow the simplest option, requirements.txt, while for PyPI packages, they tend to follow the newest trend, like pyproject.toml. So this is the experiment and also like the results of of this analysis, and I will hand it over to Maria to give us some conclusion.
To conclude, as we can just simply state, the structure and dependency declaration of Python projects looks okay. For a biomedical project, the structure sometimes would need some fixing, but the dependency declaration does not look good. If the dependency declaration does not look good, it's hard to ask if the dependency is declared match the one imported. So this is like another level of a problem. So it's a problem at that level. So that's our first conclusion. And the second, that actually you can use the data that is available in PyPI, that is available online, and create a metadata, create some metadata of the packages to get a better understanding of the ecosystem. And this is actually not as complicated and as hard as maybe we have thought at the beginning, because PyPI gives you the API to explore this data. So the next steps, how do we see what happens right now? So for us, since we are maintainers of a tool that checks dependencies declared and used, we want to explore how well the dependencies match the imported ones. So that's another step of this analysis, just to check, okay, we have the dependencies declared, so what now? Are they well declared or not really? So this is for us. And for you, the action points, either you yourself or just spread the good word and like try to help other people to get their projects better structured and reproducible. Adopt the structure per project, understand that this will help you run it later and go back to the project later. Use the configuration tool if you can, like Poetry or UV. At least that's what we are using for the project. Please declare your dependencies, because otherwise your environment will not be reproducible. And of course, check it with FawltyDeps. We wouldn't be ourselves if we didn't advertise it. And please do check the PyOpenSci web page, because they are doing a lot of great work in the open community, just to educate people, to give them tools to better package their scientific projects. So this is a very, very good resource, I think. And you can crunch the data yourself. And how? There are several QR codes that you can use here. So how to crunch the data yourself? You can use this one. This is a FawltyDeps analysis repository in which we put our code that we use to generate the presentation that you have today. But not only the presentation, we also wrote a blog post about this, which dives even deeper than this presentation into this topic. And please visit this and let us know what you think. Also, you can use the experiment branch of FawltyDeps. Oh, I'm not showing you. The experiment branch of FawltyDeps to reproduce the experiment yourself. And as for the reproducibility in data science packages, you can check the previous PyData talk by Johan, which dives deep into this problem and shows also in data how what is the status of this. And with that, I thank you.
Thank you very much for the talk. Questions? I see 2 questions here, so if you don't mind, I will pass it here and then come to you.
On slide 44, 45, you showed 2 plots that compared percentage of how many projects had their dependencies defined. From my personal experience, specifically with biomedical projects, even when dependencies are defined, they don't have the versioning correctly or something is wrong. So this plot shows let's say, something is defined, yes, no, or also the versioning is defined as well. Like,
Do you want to take it?
Yeah. So right now we just see like if it is defined or not.
Okay.
And yeah, maybe versioning is our next step.
Okay, thank you. And thank you for the talk.
Thank you.
Thank you from me as well. It was very fun. I suppose also the analysis was fun to do.
Oh, yes.
Now, a question from the PyPI packages, were all of them in active development, or was some of them more like legacy projects that were no longer maintained?
So the question is the PyPI project, were they actively maintained, or were there like a dead projects?
Yeah.
So those were the projects that were top downloaded ones in 2023.
Okay.
So I cannot answer this question indirectly. If they were not maintained, they would probably not be downloaded as much.
Yeah, I would have expected that poetry would have a bigger part than the requirements. But
that's a great comment that the poetry should have bigger take on in that. But take a look what kind of packages they are. Those are like packages that are dependencies or of other packages, like Boto-free, like who in every project defines Boto-free, but it's underneath the other packages.
Okay, yes. And I suppose some of them would not even have their own dependencies, but also use only built-in Python libraries.
Exactly.
Yeah, okay. And one last thing, which is the one package that doesn't declare any dependencies?
Do we remember?
I can't remember that well, but as far as I remember, it is like a small plugin thing.
Okay.
So, yeah.
Okay, thanks.
Hi, thank you for your talk. Regarding biomedical project, did you look also to environment.yaml file? Because some environment could be defined by as Conda environment instead of pure Python environment. So.
Yes. So the question is if we looked into what type of files? Could you repeat?
Environment.yaml file.
TML.
YAML.
YAML. Okay, YAML files that were defining Conda dependencies. In this part of project, we did not look at that. So yes, this is on us that the Conda files weren't. But then I will maybe ask the question to an audience, if I may. If you define Conda dependencies, how often is it a YAML file, and how often this is things similar to requirement.txt? Like, what is the usual way of doing that? Yeah.
Yeah, so mostly .yaml file. That's what I know from my side when you use Conda environments. And requirements.txt, it's a bit outdated, but also, like, through my experience, I thought like there is a growing usage right now of the usage of the dev containers. It's like you basically run your Docker image and you install all your dependency in it within the run command. You don't have to use any of those like fancy Python setups, like either requirements.txt or YAML files or whatever. It's just like anyone who can use like a Linux-based system, just like put a list of all the dependencies that he wants to put in his specific environment, and that's all specified in the dev container system, and just like you can use it. So this is also a nice way to like specify the dependencies within your project as well. So it's like also an alternative.
Yeah, thank you for this comment. I think we could rerun it with this check. So thank you very much for this.
Hi, great talk. Just one comment on this, and then my question. If you're using an environment.yaml file for a package, sorry, you're doing it wrong. Environment.yaml files are mostly for environments and for an application. So if you're building an application like a container, like she just said, then you're doing good. But if you have a package that you want someone to install it and use it with other packages, then it's bad practice. Ideally, you should have the .txt files or inside the PyProject.yaml, like you said. My question is, you inspect if there's no dependencies, right? But you inspect if the dependencies, not for the version, but if they are correct in a way like this package requires pandas, but it didn't specify pandas. It specified, I don't know, PyOpenExcel, because it will bring pandas with it, but it's not like the first dependence. Did you inspect for that or no?
So, okay, so let me rephrase this question. So you're asking about transitive dependencies, basically. So, for example, you have pandas, but pandas depends on NumPy, and you are using NumPy explicitly in your code, but you didn't ever declare it, right? Or not?
Sorry, my example was bad. Not if declaring the transitive dependencies, but if the person actually declared the first class dependencies. Because a very common mistake that I see scientists make is like this. Like, I declare another dependency that brings what I'm using, and I'm not really using that one. But it works. I'm not going to touch it. But if you inspect the code, you're importing pandas, right? So they should declare pandas. Did you inspect what the code is importing? That's the question. Sorry.
Yeah, so actually, I think for this experiment is like the first step. So right now we just see like if it declare any dependency or if like the code structure. And actually FawltyDeps can check like if the declared and imports are matched with each other. So our next step will like use FawltyDeps to do like an in-depth analysis.
I have a question, and I hope it's not out of the scope of your talk. Thank you for the analysis. So the biomedical software and open source software that's out there is oftentimes a product of research and universities, and it's done by students. And I had the unique experience of going back to do my graduate degree after 10 years in the industry, and I had to do student projects again, and I was used to working as we work. And of course, I'm so used to packaging my projects and taking care of the documentation and so on, but there was very little incentive, and it was absolutely not appreciated by any of the professors in any way, and not encouraged. And I had to, every single group I ended up being in, I had to teach them Git workflows. Why am I having a dependency file?
Thank you for doing that. Thank you, really.
And now I am done with that. And I think my question is, since you are maintaining one of these packages that check for dependencies and so on, is it, I don't think the research is going to adapt this kind of practices on their own just because there is very little incentive, and the way we do research is very high pressure, very, there is really no incentive to follow the best practices besides education. People might know them, but it's really not possible. And have you ever thought about, your package that you maintain becoming a check on GitHub or something, a default thing to check? Like helping, instead of having people educate themselves and introduce it, making it as part of a policy, or making it easier to access that you don't have declared dependencies? I don't know. I think maybe it's out of the scope, but I'm thinking about a solution.
So you are thinking about how to, is the FawltyDeps or other packages helping other people to keep their dependencies well defined?
Yes, how to make them just a part of a workflow that it's not out of your way, that you have to educate yourself, but it's integrated in something that people...
Okay, so in that particular case, FawltyDeps can be integrated as I think like a pre-commit hook right now. We are working on GitHub action, so it can be easily integrated into the CI. So you don't even have to think about it. It will be screaming at you if you are doing something wrong. That's one thing. Another thing is the PyOpen side that I mentioned before. This is more on the education side, but it is pretty well written, and I think this could be like a starting point. And I also would like to address the fact that they do not have incentives, the scientists, because I also worked with them a bit, and they come to me just exactly with this problem, that it is not reproducible. Please help us how to do it. So like teaching them even the smallest good practices like using Git really helps them a lot. And there is an interest, at least in Poland, there is from like middle-level scientists, like doctoral, postdoctorals, doctor professors, like people like that. At least I experienced that, so I hope it will propagate something.
Thank you very much for a very interesting talk, and thank you for a nice discussion. So I think now it's time for the break. You can continue discussing in the break. Thank you.